up next is the talk about the dry conditions in Southland, how we got there, what's going on at the moment, and the potential for rain over the next next 4 weeks basically, and how and we could touch a little bit on how that forecast is produced as well. So these are two snapshots, one from a week ago at the top and one from yesterday at the bottom. Now, these charts are showing soil moisture deficit, which is, it's a theoretical representation of how much moisture is in the soil, basically. There's a theoretical maximum deficit of 150 millimeters. If you've got minus 150, the idea is that soil is completely dry and there's no moisture available at all. Obviously, that's a bit of a simplification depending on soil types and vegetation types, and obviously urbanization as well creates a big problem for things like this. But it does provide us with a very good steer on, you know, the drought conditions, the potential growing conditions, and potentially you know, damaging conditions for, you know, plants basically as we go forwards. If we look a week ago, almost all reds and oranges, and those are very dry conditions. So significant soil moisture deficit is 110 millimeters less than normal. And this is equivalent of millimeters of rain, by the way. It doesn't translate directly, but it's a pretty good estimation. And those red colors in there, though, minus 130 millimeters, that's almost a bone dry soil. You know, that you could see that quite easily just being, you know, starting to lose its structure and becoming quite a broken, dusty mess, basically. But if we look yesterday, we've seen an improvement. It's not all the way, but it's been something. The blue colours over in Fiordland represent saturated soils or even super saturated soils where you've got some surface water flooding. And the yellow represents still moderate soil moisture deficit, so you'll still see some stress on plants. And green is a minor soil moisture deficit, which if you're going the other way, if you're drying out, you probably haven't started to see a huge amount of plant stress yet. But if you're coming out of dry, you really need to get to these sort of points before you see much in the way of recovery. You know, a regreening of the grass, which may makes things look better than they are because the underlying soil is still very dry. So what happened to get from a week ago to today? Basically, around the turn of the month, we had a few showers around. That didn't do a huge amount. We saw about 5 millimeters of rain. It was quite spotty. Some places didn't see anything at all. And then on Wednesday and Thursday this week, we saw more meaningful rain. So we saw northwesterlies on the late Tuesday into Wednesday, which brought a pulse of still pretty disorganized rain, actually. It was quite showery, I think, as it came across. And then a cold front on Thursday morning turned and basically turned the winds around to the southwest and ran out the country, bringing much cooler temperatures, but it brought some reasonable rain as well. And from those two events, we saw around 10 to 30 millimeters of rain. Most of the rain fell in the west, where you can see we've got two, you know, up to some of more like dark green and blue type colours, and the east was left picking up the scraps. It's worth noting that when soil moisture is low, when soils are dry, it can change very rapidly. It takes quite a while for things to change sort of around that midpoint, but when things are very dry, the soil accepts that moisture very quickly, but also it evaporates off again very quickly. So why did it end up so dry? You've got to cast your eye far away up towards the tropics into the central Pacific Ocean, and we've had basically 2 straight years of La Nina conditions. Now, La Nina basically is where the surface temperatures of the central Pacific Ocean, the surface water temperatures are cooler than average. And those cooler than average sea surface temperatures enhance the easterly trade winds, which then in turn creates more upwelling, cools the waters, stronger easterly trade winds. And that then passes all the way across through just south of the equator and comes across to our longitudes, where that effect is weaker. Because that effect is weaker, the easterly trades then sort of start to die off, and as they curl around, they create a tendency for higher than normal pressure to form near the Chatham Islands and lower than normal pressure to form in the Tasman Sea, and particularly northern Tasman Sea. The chart you can see in the bottom right there, that is the pressure anomaly, so the departure from normal for the time of year for the last 3 months. So you can see much higher than normal pressure through the Southern Ocean and extending towards the Chatham Islands, and you've got that lower than normal pressure up, in fact, just south of New Caledonia, where Tropical Cyclone Feely is currently churning away. What this serves to do is two things. Once you've got that blocking high in the Southern Ocean, you cut off the feed of westerly weather systems, so we don't get the usual progression of westerly fronts moving onto the country, and usually impacting a ridge that's around Northland at this time of year. We're seeing quite the opposite now. So those westerlies don't come in. So basically, there are fewer weather features on offer to bring rain in. What they also do is almost reverse the usual circulation around New Zealand. A fairly standard wind direction, as I'm sure you'll be aware of, is southwesterlies come in blowing cold with a few showers. But when you've got these high pressures set up near the Chatham Islands, that's flipped on its head. So you get northeasterlies. Now, because New Zealand is aligned in a southwest northeast direction, Southland finds itself very sheltered in a northeasterly wind direction. You've got the whole country upwind, grabbing any rain that's coming in those wind directions. So anything that comes in from that direction, you're really only picking up the scraps. So the two factors at play there are fewer westerly weather events coming in, so fewer rain events on offer, and those that do come in are usually significantly weaker. And also, when you get rain events from the northeast, there's just so much mountainous terrain in the way that you really struggle to get real appreciable rain from those. The forecast, as you can see on the graph to the left, though, is potentially positive. You've got La Nina weakening off. Now, there has been a trend for this to delay over the past few runs, but as La Nina weakens off and becomes neutral, likely in late May, potentially early June, it would be quite a prolonged one. If it does last into winter, once that happens, we start to see it release its grip, and we start to lose the usual sort of La Nina pattern with high pressure in the Chathams and lows in the northwest, and we start to revert back to something more normal. One thing to bear in mind is that such a big, strong driver like La Nina, it creates an almost like event horizon where computer models really struggle to see beyond it. Because one thing that happens is that they come through that transition and they end up in different places. So they come up with different decisions after that. And what that basically means is you end up with quite a wide array of solutions for which climate drivers are likely to come to the fore next. And this is a classic problem when you go through a big weather event. So in the long term, it's the end of La Nina. In the short term, there's another one of these event horizons actually on the other side of Tropical Cyclone Feely, which is due to track somewhere to the north or northeast of North Island early next week, and that in itself is creating this sort of ball of inertia, which even short-range models struggle to see beyond. So they do create problems, but these climate drivers are useful in identifying why we've had such stagnant patterns over the last 2 years. But they don't work in isolation. La Nina has a friend who works with the Southern Annular Mode. So the Southern Annular Mode is usually the main player for New Zealand, and especially for Southland. It's a measure of how far north or south the usual ring of stormy westerlies in the Southern Ocean sit. So if you picture, the usual map we see of the globe, where Antarctica goes from left to right all the way across the bottom, it's not quite as obvious. But if you rotate that and you look at the Earth from the South Pole, you can see there's basically Antarctica as a circle, and then there's just no land in the way for several degrees of latitude. And what that does in there is it allows the westerly winds that are at that latitude to really swirl around the world. And when they migrate towards the north, the Southern Annular Mode is said to be in its negative or its unsettled phase. And that's when it starts to impact the southern land masses. So it starts to flick off, South America, South Africa, gets to the southern portions of Australia, and it gets New Zealand as well. What you can see looking back from this graph, though, all the way to September 2021, it's mainly red, it's mainly positive, and it's mainly strongly positive. And when the Southern Annular Mode is positive, this ring of stormy westerlies are diverted much further south, and they stay in the Southern Ocean, and they don't affect the land masses. So when it's strongly positive, we see more high pressure across South Island, more high pressure across Southland, and that was represented in that previous slide where we saw the strong reds across the Southern Ocean and the lower South Island. And that means that there's even fewer of those westerly weather systems likely to come in, and those that do come in really struggle to make rain. When they come in, they're sort of weakened by the proximity of that high. There is a demonstrated positive feedback between La Nina conditions and positive southern annular mode. So these two, they're not in conflict with each other, they're working together. And the fact that La Nina promotes high pressure near the Chatham Islands, then in turn promotes the deflection of those westerly storms further south. So those two climate drivers basically working in conjunction over the past, 18 months to 2 years to see very few, major rain events running through. It doesn't mean that the ones you see are any less intense, but it sort of means they're less likely to come through. You can see there's a few quite negative spikes there over the past sort of month or so, and this is a sign that La Nina is weakening, losing its grip, through that mid-October to sort of early February part. We didn't see any negative really, but we've started to see some negative spikes now, so we're starting to see some of these rain events move in. And encouragingly, you can see the front that came up earlier this week is the most recent solid blue bars, and then the sort of the bars rather than the solid color there, the forecast for the next 2 weeks. And that forecast for the next 2 weeks has 2 Southern Ocean events in there. You've got a high pressure in the middle, which is that red spike, but those 2 blue sets of bars pointing down, you've got a rain event potentially coming early next week, which is not associated with ex-tropical cyclone Feely. It's a Southern Ocean driven system. And then the one right towards the end of the forecast range there is a little more uncertain, but we'll look at that a bit more as we go further on. We know it's dry, but how dry has it been? So the red lines are this year so far. And if we take March, our most recent full month of data, both Gore and Invercargill set their record for the driest March on record. So Gore's record goes back to 1968 and set a new record of 13.6 millimeters of rain. You can see basically a flat line from left to right through March. Invercargill's record is impressively long, goes back to 1939, and only 17.8 millimeters fell this March. You can see the little blip right at the end of that, which is the front that ran up earlier this week. But it's still not dragging that line anywhere near to average rainfall, and that's the average from 1981 to 2010, and that's the black line in there. So whilst this year in isolation looks, bad and dry, if you look at the 2021 line, which is green, that's also well below average across the entire year. And for Invercargill especially, you go back to 2020, and that is also significantly drier than average. So basically, the whole time that we've had this La Nina in charge, the lower South Island, and particularly Southland, has been struggling to get appreciable rainfall. And yeah, we've had this much drier than average period. So I did mention that there was some rainfall on the way. Here are the three main global models. So on the left, you've got the GFS, the Global Forecasting System, which is run by NOAA, which is the American National Meteorological Service. In the middle, you've got the Unified Model, which is run by the UK's Met Office. And on the right, you've got the IFS or ECMWF, the European Centre for Meteorology. I forgot what the MWF stands for. Basically, it's the European sort of conglomerate that work as a forecasting centre based out of Reading in the UK. And that's their model on the right. These are 3 projections for midnight on Tuesday night going into Wednesday. All 3 of them show a decent amount of northwesterly rain moving onto the lower South Island. It doesn't look like it moves particularly quickly, but which is potentially a good thing. So you've got Tropical Cyclone Feely at this same point will be somewhere north of Bay of Plenty, potentially, although that's subject to change. But what that does is it potentially slows down this rain band that's coming through. I think at the moment, it looks like the most likely scenario is for around 80 millimeters of rain for Fiordland, which is a reasonable amount. That's about average for a week, and they probably get it in about 36 hours. But that's not an unusual way to get your rain. Further east, probably 20 to 40 millimeters of rain. So it's not necessarily a drought breaker, but it's definitely good news. The heaviest rain is most likely to be across the western parts of Southland, whereas the east is the most likely to miss out on most of it and sort of struggle with the 20, perhaps 30 millimeters of rain there. So there's some rain coming early next week, but it might not be enough to solve the huge problems. TC Feely, though, it'll be grabbing headlines and for good reason. It creates such an inertia as it comes out of the tropics that it disrupts the environment around it. So the weather systems don't act in isolation. This graph that we've got here are the probabilities of different amounts of rain falling at Invercargill on different days. You could see, if we look at today, for example, this is only more than 1 millimeter. That's hardly any rain, but it's happening. There's a couple of showers. Tomorrow, we've got high pressure moving in. It's very dry. High pressure sticks around for Sunday as well. That's why you've got this 30% chance of seeing more than 1 millimeter of rain. It's going to stay dry, basically. When we start getting into these larger colors and these larger percentages for the darker blues, that's when things get a bit more interesting. Because also these aren't just one or the other, This event spreads from potentially Monday into Tuesday and perhaps spill over into Wednesday with a few showers as well. So it's not unfeasible that you see 10 millimeters here, 10 millimeters here, and 10 or 20 millimeters here. So what this graph is basically showing is the chance of a meaningful rain event. And because TC Feely is doing its thing up north and it's potentially disrupting the high pressure that's given us such settled weather for so long, we start to see something creeping in here for Saturday 16th, and we see something creeping in here around the 19th and 20th. And what I think is happening here is we're dislocating that high. So we're moving it away and it's shifting potentially to the east or potentially to the north. But either way, that allows westerlies or even allows northwesterlies to run onto the lower South Island. Both of those are much, much better directions for producing rain. The front on Saturday 16th is likely to be very weak, maybe just a few showers. But the one around the 19th and 20th potentially looks like it could be the onset of a few days of this westerly mobility. So like a few days where you maybe don't get a huge rain event. You don't see 100 millimeters in 10 hours or whatever. You end up getting 20 millimeters a day or 10 or 15 millimeters a day, and it just sort of gradually ticks up. And that's the kind of rain that pulls out of a drought probably better than one huge big rain event, which ends up, out of the frying pan into the fire, and you end up with flooding because the ground's so baked hard. So potentially, as we look towards the end of this forecast period and towards sort of the second half of April, if you will, there's potentially good news in there. But one of the other ways we tend to look at longer range forecasting is these forecast anomalies. So these maps are the projected rainfall departure from normal. And green is coloured wetter than average, and the orange is drier than average. And if it's not coloured in, it's sort of give or take near normal rainfall for the time of year. The scale is not hugely important on this. It's more because I think this is a 4-week model and this is averaged across a whole week. So you struggle to pick out individual rain events. So the scale is not as important as the color, basically, that it's going to be wetter than average or drier than average. You can see for next week, you've got that front running up to South Island becoming very slow moving and not really pushing onto the upper south. That's producing a wetter than average week for the western side of the lower south. Probably brings you near normal or perhaps a touch wetter than normal across the rest of Southland. The following week, where I talked about we may have the onset of that period of westerly mobility, or we could even have northwesterlies, that second week there also looks like the potential to produce reasonable rain. However, we're not out of the woods of La Nina yet. It still has a grip on our weather maps. And the pattern from the 25th of April onwards for those 2 weeks looks decidedly La Nina-like. It shows quite a strong high pressure near the Chatham Islands, and it shows low pressure to the north. So you can see, if you look at the upper North Island, for example, they're picking up northerly rain. Gisborne and East Cape picking up easterly rain in that 4th week. But it's that direction, it's that northeasterly that really struggles to bring rain to the lower South Island. So whilst the forecast is not all doom and gloom, it's not necessarily for a lot of rain either. There's basically fractured rain events through the next 2 weeks, and then we may go into another drier period. So it looks like we've probably broken the out and out dry that we saw through March. It looks like April doesn't run that way at all, but it looks like we might trend back towards something drier through the end of the month and perhaps into early May as well. So that's my roundup of how dry it is, how we got there, and how we may at least come out of it a little bit over the next couple of weeks. And I will now have a look at some of the questions. Thank you for listening. I have from Rob, is that a significant improvement? Was this in relation to the soil moisture deficit charts? I think it probably was. Yes, basically. It changes quite quickly at this time of year when the soils are fairly dry. But it's one of those things where you see it improved quite quickly over a week. It can also deteriorate quite quickly as well, especially if you get those northeasterly winds, because you get a feature called the Föhn effect, which basically creates a drying effect of the wind as it comes over high ground. So it makes it warmer and it makes it drier if you're on the downwind side of the mountains. And if you've got all of New Zealand to come across with all this, magnificent lumps and bumps, you end up with a much drier wind blowing across, and that serves to dry your washing very quickly, but it also serves to dry your soils very quickly. So things can change very quickly at this time of year, basically. Nikki, do you map ground temperature alongside soil moisture deficit? There are ground temperature sensors around. They're not used hugely. I don't think every automatic weather station has them, but they usually measure at 10, 30 and 100 centimeters of depth, I think. And quite often at this time of year, the meteorologists will be looking at those ground temperature sensors for potential settling snow rather than for soil moisture deficit. Are the accumulated graphs available online? Not that I'm aware of. I made these for this presentation. Are we able to access various model outputs from different agencies if we're interested in looking at a selection of forecasts? Yeah, there's various sites out there where they either grab a lot of the model data together, or there's each individual MetService has their own site where they make a lot of them make their data freely available. And casting back to the first half of the presentation, that's actually one of the good things with the World Meteorological Organization. You'd think I'd be able to say it. Have sort of spearheaded where we have this free transfer of data and we make data freely available. So it's in the sort of best interest of meteorology and science rather than the best interests of any one Met-Service. How frequently are the models run per day? There's myriad answers to that question. If you look at the most recent slide I showed you with those for 1 week, they're run twice a week. So they run on a Monday and on a Thursday, and the computing power necessary to run those models is so vast that the data is actually not available until the following day. So they run twice a week. And then if you look at the global models, where I showed you a snapshot of 3 of those, most of those are run every 6 hours, but they will have main runs, which is usually the 00 and 12 hours. And all of this is done in universal time clock. It's done in UTC rather than any local time. So they've all the models, from no matter where they run, have got the same timestamps on. But in terms of how often they run, yeah, the global models usually every 6 hours, but the 12-hourly runs usually extend further. They have a longer validity period. Going down smaller than that, so we have our local area WRFs that we run here, the weather research and forecasting models. Most of those are run 4 times a day, but we're also experimenting with high resolution rapid refresh models, which can refresh and run again every hour. So that's really the sort of cutting edge of modeling at the moment, and some of those have got machine learning built into them as well. So in terms of how often models run, it totally depends on the model, and most of that is determined by the computing power and the time it takes to run. So if you think these models run on massive supercomputers, and some of the data takes several hours to run based on the resolution and the domain of the model, you can see it takes a lot of time to do, hence why if you run a high resolution model, you tend to run it over a smaller domain. Jason, of the 3 models used, is there one which is considered to be more accurate for our region? Can they potentially create conflicting information when creating forecasts? They potentially can, and they do all the time. All the time, the models will show you something different. Even if they're very similar, there's something different in each model. And that comes down to the expertise of some of our expert meteorologists to assess which models are performing the best. And that's that can be done in a multitude of ways. It's not necessarily done on, it's not necessarily done on the wind in Invercargill, for example. What you tend to look at is a much broader picture. We've got different channels of satellite imagery, so we can look at visible images, which is what the eye would see. We can look at infrared images, which is obviously what an infrared camera would see. But we can also look at something called a water vapor image, which shows you basically the water content of the upper third of the atmosphere. And that's very useful for seeing things like the jet streams and potential areas of different forcings and different developments. So you can assess the models quite intensely through that and decide which ones are performing the best across the area. We say of the 3 models used, there's more than that. There's loads more. The BOM have got one they call Access. We've got there's a Canadian model, there's a German model, there's a Japanese model. There's this, but the 3 that I put up with they're sort of considered the 3 main models, and generally there is a preference for the ECMWF model around New Zealand. It works quite well with our latitudes, but you'll see, there's no sort of allegiance to any model. The allegiance is to the best forecast at the time. So the meteorologist in question will be more than happy to pick a different model on any given day, depending on which ones are performing the best. Is Southland expected to experience more of these dry events in the future? Now, I'm not a climatologist, I'm a meteorologist, but there has been a link established, and I forget the author of the paper, a link established between a warming climate and an increased incidence of positive southern annular mode, which is necessarily not good news for Southland avoiding future droughts and dry spells like this. So yeah, I can't talk in any great length about that, but I have read somewhere that there was a link between a warming climate and increased incidence of positive southern annular mode, which is higher than normal pressure across the lower South Island and across the Chathams, so more northeasterlies and fewer of those westerly rain events. Bruce, back to red warnings. Several were involved in the emergency response in the 2020 Southland flood. Is it fair to say that the red warnings have played out in practice pretty closely to predicted, useful for informing our future decision making? So these are huge events when these happen, these red warnings, and the decision to step up to red is never taken lightly. But if the threat's there, it's also not ignored. I don't have offhand a verification of how these red warnings have played out, but there aren't too many of them. And just from my own recollection of being on shift when these things have been happening, I think because we only go to red warnings when confidence is high enough to pinpoint a certain area, I think they generally go pretty close to predicted. It's interesting to look at sort of the watches and warnings tree as you approach a red event, whether the watch was out in good time, and then there was a step to a more broad orange warning, and then it was really zoned in both spatially and temporally to a red warning. So yeah, I don't have any empirical data on me about how well the red warnings are verified, but just anecdotally from when I've been on shift, I think they tend to go pretty well forecast, because also they focus quite a lot of the efforts of the forecast room as well. So Jason was asked in relation to the rain prediction model for next week. Was that the... Sorry, I'm just scrolling back. So the question about the 3 models used, which one considering most accurate for our region, that wasn't in general for New Zealand. That was for Southland for next week. It looks probably most likely, I'll scroll back to that chart, of these ones. At this point, this has been the most consistent model. And one of the things we do, so these basically, and I think we've still just about got time to touch on this, and apologies for not having any graphics to show, but at least I think it's interesting. These are deterministic models. These basically run and they give you one answer each. So they basically come up and they give you time steps every 3 or 6 hours of what's happening at that time. And you can look at those and assess how well they're performing. But one of the things we do at longer lead times and for significant events, and we actually do it all the time, but they're most useful in those scenarios, is do a thing called ensemble forecasting. So if you take this one run here on the right hand side, that's their deterministic model run of the ECMWF global model. It's got a 13-kilometer resolution. It's got, I think, 70 vertical layers, and it's a very good, well-performing model. But it's just one answer. And if you cast your mind back to the observations that I talked about going into the model, we don't observe everywhere. These models are not perfect, and they're never going to be perfect. So what we do is we've run an ensemble, and what they do at ECMWF is they have 51 models which have the same physics as the deterministic model, and they have the same resolution. One of them has the same starting conditions, and the other 50 have perturbations. So they change the starting conditions, just tiny amounts, just very tiny amounts. And what that does is then when all the models run, they sort of go off in slightly different directions. Sometimes they come back together, but they go off in different directions. And what that then gives you is a probabilistic spread of possible scenarios. So if you did that with, say, 2 models, you wouldn't know which to pick. But because we're doing it with 51, you can take then a median of those models or even a mean of those models and have a statistical analysis of what would most likely to happen with the weather in any particular time frame over a given period. And I have looked at the ensembles for this, which is where I got those forecast numbers from. So I didn't take my roughly 80 millimeters for Fiordland from any of these deterministic models, especially if you look on the left where you can see it's hardly raining at all. I took those forecast numbers from the ensembles, which gives you a much broader spread. And you do a thing where you take what's called the interquartile range, basically, where you can take the 25th percentile and the 75th percentile. So you've got half of the ensemble members fit between those two values. And that's how you can get a forecast of rainfall ranges, say 20 millimeters in the east and 40 millimeters in the west. Do we have any more questions? I think we've still got 5 minutes if anyone's got a burning question. Be careful what you wish for, Nikki.
All right, I take it there's no more questions. Question from Rob. At what point will this be repeated? So this presentation was organised as a one-off. However, we could possibly look in the future to do some more of these. Just want to say a big thank you to Jake. I definitely found this presentation very interesting and learnt a lot. It's fair to say that there's a lot more to weather forecasting than what I realised.
Yeah, thank you for having me. I really enjoyed it.
And if there's no more questions, that'll be the end of it. I hope everyone has a good weekend.
Yeah, thanks everyone. Enjoy your weekend.